You didn't miss anything. Don't worry.
Yeah, no, we've been just kind of working through some technical difficulties. Goodness gracious, it took a while to get everything up and running. We have like 15,000 different things we're trying to show all at once. So just to kind of be clear, this is going to be a lot more informal than our previous discussions.
If you couldn't tell already. Yeah.
Yeah, so we're not going to be just showing like a PowerPoint. It's going to be more of a like, hey, I'm here, and you're there, and here's some data and stuff, and we're going to do some cool stuff with the data. So the goal is we're going to take what's going on this EEG that I'm wearing right now. You see this here? I have become the brain-computer interface. Anyways, that said, the BCI is going to be sending data over what's called Lab Streaming Layer, or LSL. And LSL is awesome because you can do literally anything with it. You can just have it send data over the internet to my other computer. I can have it send data from another device. I could, let's say, create a simulation, have it set up a stream. I could take some streams of EEG into it. I could generate a new stream after reading the EEG, classify it, and then create a classifier stream. I can create whatever stream I want and stream it to anywhere I want. And that makes LSL super awesome. And so we use it to do experiments here at NXT. So we're going to kind of like walk through how that works. Right now Harrison is setting up a connection between my computer and this computer so that we can show you a little prosthetic simulator that we have created that not only accepts streams from Live Streaming Layer but also generates streams for Live Streaming Layer. So we're going to see if we can actually visualize that on our screen.
Good. This is going about as well as I would have expected it to. Your Gmail was loading too slowly for me to send any emails out. So that is why, because I've got the things copied, but this is just infinitely, yes. Again, so you missed this before, but if you have 5,000 tabs open in Chrome, bad idea.
Yeah, I mean, like you can't blame me for having a wide variety of interests. Like that's just kind of how I do.
I like that we're doing this joke twice, and none of these.
Yeah, no one's in the
inside, and we're doing it again. And my response to the first time Forrest said that was, "It doesn't matter if you have many interests if you can't read a single web page." Anyway.
All right, so my wide variety of way too many interests notwithstanding.
Yes, he has a computer with 8 gigabytes of space and so many tabs that I can't load a single one of them.
Yeah, so to kind of walk you guys through like what's going on right here, this here is the OpenBCI GUI, and we have it currently streaming using this thing called the OpenBCI Hub. You got to open this first, and then you open this, and then that way you'll actually not have a million thousand bugs trying to figure out what the heck's going on. But once you got that working, then you can see the streams to verify that you're actually getting data. If you see like a bunch of this, right now I'm blinking a lot. You see all these little jumps here? Those are blink artifacts. They're pretty big compared to the actual EEG signal. So you'll see that this just auto-scaled, and you couldn't see any of the EEG. So it just kind of gives you a sense of what the heck's going on here. Is like, wow, this signal's big compared to EEG. So you really got to take care of those artifacts before you do any sort of analysis on this. So now that we've kind of verified that we have a stream working, I'm going to go ahead and close this and make sure I stop the connection to OpenBCI GUI first. And then we have this kind of other setup that we've got going on in here with this thing called Lab Recorder. So this is what we use to record different LSL streams. So you can see right now my Unity stream is currently being streamed over the internet to this computer. So that's my Lacility left, Lacility right. So those are the left and right hands. So I could record those if I wanted to, but right now I'm not going to. But you can notice that my EEG is currently not streaming. Well, the problem is the EEG is not directly connected to Live Streaming Layer. We have to create our own stream. So there's a wonderful tool that someone created called OpenBCI LSL. And you can give thanks to the University of California, Santa Barbara for creating all these LSL tools because they're pretty fantastic. Not going to lie. So I'm going to go ahead and open up PowerShell, and I'm going to move to this directory. So copying that directory, CD, and then I'm going to use Python. And you have to make sure you have some libraries installed. They're kind of in the requirements document, but their website also describes what you need for this. So I'm going to, I think I actually have this preset, yeah. And just to verify which COM port I'm on, COM7. So if I'm on COM7, I have to change this text. So it says COM7 -- stream. And now it should set up a stream. It's established a serial connection. And this is the setup that I have. So you can see I'm currently getting the accelerometer data as well as the EEG. So 8 channels, 3 channels. And then in addition, give me a second. I don't know if that, okay, I guess it worked. Maybe, okay, hold on. Just tried that I was talking about before. So you can see that these are the different electrode locations we have connected. You have to make sure that they're connected in the correct order. So the order that you see them showing up on the screen here is actually the same order that they're connected along the board from left to right on the board. So if you're looking down on the board with the pins facing this way, 1, 2, 3, 4, 5, all the way out to 8, like you have to connect those in that order so that they show up correctly in the GUI as well as stream correctly through LSL. So now that we know I'm getting a good stream, the first thing I'm going to do is set up a connection to LSL. So I'm going to type /start. Another thing to remember is when you want to stop doing this, before you turn off any of the hardware, you must type /stop and then /exit so that it disconnects from the hardware. Then you can turn off the hardware, because otherwise you end up having to reset all of the hardware again if you want it to connect correctly, because otherwise you end up with this problem where it won't connect for some reason. So now that we have the LSL string running, you should be able to see it here. So if I click update, voila, we have an OpenBCI stream. So there's the accelerometer and the EEG. Then the next thing that we're going to want to do is there's this wonderful little apps thing we have for LSL. And you can see we can collect a whole bunch of different types of information. You can collect from a Wiimote, of all things, or an eye tracker, or let's see what else we've got in here. We've got a mouse. We've got this MATLAB viewer application that lets you kind of view the EEG. I'm actually going to show you that later. And another thing is this wonderful tool called the keyboard application. And it looks really silly and like really simple. It's just like there's a link thing. There's not even a minimize button. But actually, I can click this little corner button here and it'll make it kind of minimize away. So now what that did was it just linked my keyboard to LSL. And there it is. So now I can actually record keyboard events. So when I can actually conduct an experiment, I can actually see when certain events happen. So let's say I tell someone, I want you to switch between fist and open state in your mind. I want you to just think about making a fist and then think about opening your hand with your right hand specifically, and only change your state between those states when I push a key. Then the way that I verify that they were correctly following things afterwards is I ask them, what is the state that you are currently in, without like being consistent in where I end. So I record variable lengths of transitions, and then I only use up to a certain number of them so that I have the same number of them between all of my different sample sets. So that's the kind of randomization that I do to verify that the subject is in the correct position at the end of the process, to make sure that he's following along. Can you turn that off? Okay, thank you. So now that we have the connection going to LSL from our other stream, so you see this Lucility left, Lucility right. So we actually have this little stream over here. This is our little prosthetic simulator, and you'll see that right now we're currently connecting this over LSL. So you can actually collect the stream through this little application and record it alongside the EEG if you wanted to. But the interesting thing about this is I actually also already have, oh my goodness, there. I already have a MATLAB interface here that is currently reading the angles of all the fingers.
Keep an eye on OBS too.
And if you go back into this application and you click open, if this actually doesn't freeze on me, or fist, you can see that when you go back to MATLAB, the position of the left hand is now at 0, which is the fully closed state of the left hand. So you can see the angles of each finger being output alongside a timestamp signature on the right. And so the nice thing about LSL is that it time synchronizes all of the data that comes in, and you can use that to then link things together to determine when certain events occurred. And then you can use that when you're doing machine learning to say, okay, I know when all of these particular pieces of data were streamed. This is also why it's important that you stream at similar sampling rates, because you don't want to end up with like, oh, I have this really high resolution data and now I can't relate it to this other data, and that becomes kind of like not as useful. But there are ways around that. Like you take certain groups of those samples and then you turn them into features that match up to a certain range of the smaller samples set for the other one, and then you can do some analysis with that still. So that said though, so now if we wanted to do a recording, let's say, for an example, I'll have Harrison come in and help me out with that. So you see we've got the keyboard set up right now and I'm set to record the keyboard. So what I'm going to have Harrison do is I am going to switch between eye open and eye closed states on a press of a keyboard. So I'll start with my eyes closed, And when my eyes open, it will be when he presses the O key on the keyboard. And when my eyes close, it will be when he presses the C key on the keyboard. So I can start this stream. And if Harrison presses the button, I will open my eyes.
Okay, go ahead. Open.
I didn't hear a button press.
Well, I've been pressing them. Open.
All right, pause 1 second. Yeah. So this is one example of a situation where it's difficult for the subject to tell that there's an event going on. So this will happen to you sometimes during your testing. So what ideally should be done is when the person is pressing the key, they should press it loudly enough that the subject can tell. Now the problem with this, of course, as you might be able to tell, is that with EEG, the sound waves get picked up as well, and that affects your EEG. So ideally what you'd like to do is find multiple different ways to create a stimulus so that the subject can get a sense for like what's going on so that they notice which states, but at the same time you still have data representing when the events occur without having this kind of correlation between the sound and them actually doing the event. You want to make sure that you can separate those two things. So to do that, you would have to record this multiple times with different stimuli.
Right.
But we're not going to do that here because we're not really interested in separating it that way. We're just looking to see that we can actually identify this at all. So
loud button presses.
Yes. So you're going to start by pressing O. My eyes will stay closed, and no, before when we start recording. And another thing is, so I can actually select which directory I want to save this in. So for our purposes, I'm going to put this in C/recordings/ I'm going to call this stream LSL.xdf. And basically, when I start recording, my recommendation is that you wait for the subject to kind of be in a relaxed state. You want to make sure your hands are relaxed in your lap, and you want to wait about 5 seconds before you start pressing buttons, and then 5 seconds after you've finished doing that for about a minute, so that way you can get enough samples. And that way you have enough time to ensure that you have enough time after when events occur and before when those events occur to be able to do time shifting around the signal and not worry about there being some noise from them getting ready into a position where they're like comfortable to wait to start doing the experiment. So it's just kind of like accounting for various different potential factors that could be creating issues in your recording. So if we'd like to begin, whenever you're ready, Harrison.
So I want to be clear. I'm going to wait 5 seconds, click this, and then I'm going to hit that for close, hit C for
close. You're going to hit that first, right. And then you're going to record or wait for 5 seconds, and then you'll start pushing buttons.
Okay, so waiting 5 seconds. You want me to click the C for close?
Yes. My eyes are open. Then
Your
yes.
eyes are closed right now. Right?
So you press O to open.
Oh, okay. Ready? C to close.
Harrison, what mode am I supposed to be in?
That was open.
Okay, so then we're good.
So go ahead and stop.
Yep, go ahead and stop. So this is one example of a recording done using LSL with the Lab Recorder tool. Another thing is that we can actually use MATLAB to visualize what the EEG looks like while we're doing the recording. So if we go into MATLAB, if I can get it to open, I don't know. It takes a while sometimes. Oh, is it already open? No. Does not seem to want to open. Technical difficulties. I see. It has 15 of them trying to open all at the same time.
I would do it. There you go. last time I checked, there was someone watching, so apologies for everything.
Yeah, I mean, that's just kind of the nature of the work, you know? Like, when we're working with something this complex, there's too many parts moving around for anything to work perfectly, as expected. So you always got to do some testing when you start up. You know, when you're working with, like, analog sensors, for example, like, you got to, like, calibrate before and all that. So it's definitely something to think about. We're also using 100% of this computer's CPU right now, so I would not be surprised if we have any major issues.
There you go, 90% memory. This is good.
Yeah.
And you know, sometimes, so of course, there are a lot of complexities that go into this. We spent a lot of time setting up the OpenBCI headset before we started, and sometimes it's simple things like Google Meet. That can be a problem too. So there you go. All right, CPU is calming down a little bit.
Yeah, so MATLAB must be just about finished running to start up.
Yep.
So while we're waiting on that, I wanted to kind of like show another thing in the Google Meet thing. So to kind of go back to the whole Facility stream thing that was going on. That's what we call this simulator. Can you switch to the left there? Yeah, so you can see that this is like the simulator that we currently have going on with both hands. And if we go into the way this is working, here's what's called Unity. So Unity is a game engine. It basically allows us to create simulations of things, but you could also use it, for instance, to make a video game if you so chose. So basically the way that we're going about this right now is we've created a bunch of blocks and cylinders that we've kind of arranged so that way they can move relative to one another according to an angle that we input. And so it's using relative transformations. So if you guys are familiar with robotics at all, then it uses relative rotations at each of the different joints to control how each of the different limbs or components of the limbs move. And so if you go into the hierarchy is what it's called, then you can see what we have currently in here. So we actually have this little thing called a resolver. So if I move the inspector over, you can actually rearrange all of the different windows that are in Unity. In the resolver, you can see all of the currently active streams, and look at that. The OpenBCI that's connected to the other computer shows up on here. So we can actually stream over the internet, as long as we're on the same network, to all the devices that are in the room, which is fantastic. But you see here I have it set up so that it's specifically looking for a locality state inlet. So that means something has to be streaming a locality state. So that's it. For the way that this is defined is if I send a classification of one of the states that these hands are able to go into, which if you remember from seeing the hands, that would be relax, open, fist, and point. Then if I send one of those states as a number from 1 through 4, then the hand will move to that state. So we actually have a testing system for that. It's not running right now because there are too many steps to get all of those things all running at the same time. But I think you guys kind of get the point that you can create a sort of inlet and also an outlet system to provide the results of what each of these hands is doing. So if we went into the prosthetic tester, you can see we have this locality state inlet that allows it to control the transradial controller. So we also have a system that allows us to send data from these, and so it'll send an outlet that gets sent over to MATLAB, and that's how this is being read right now. So this is just like on each of the fingers, it's taking that data and giving it to the prosthesis, and then the prosthesis on both ends is sending all of the data to one system that sends all of the data for this entire simulation. And so that's how this whole simulator system works. So to give a little bit more context for what Unity is, so when I edit something while it's playing, that doesn't stay edited forever. So if I were to go into this and if I were to just delete something, like the event system, now it's gone. If I unplay it, you'll see it comes right back. So that's one of the wonderful things about Unity is you can test things while it's running and it won't break anything. In fact, if you have an error, it'll print an error in the console, which is what this is. You can actually use a thing called debug.log to print a bunch of things out there, or log error if you want to log an error, or log warning if you want to just log a warning that isn't like an error exactly but could potentially cause an error. Then you can print those all out to the console. You can even collapse similar posts from the console into single posts. So you'll see there's a number here because there's only been one warning that was logged with this information in it. If there were multiple, this would be a higher number. So this makes Unity very, very useful for prototyping. There's also Unreal Engine, but I've only really worked with Unity, so it's a little bit harder for me to explain how Unreal Engine works. And the language that Unity uses for scripting is C#. So you can see this is kind of like what it looks like on the inside. This is an example of the LSL for Unity package, which is the package that you would need if you wanted to use LSL to interface with Unity, this game engine. And so this is kind of like how our whole setup works. But just to kind of, I guess, finish it off, I want to show you one last thing, and this is called VizStream. So you can see that there's a little bit of like code in here that like talks about like what kind of information you can give to this thing called VizStream. You can tell it what stream you want it to look for. You can tell it what the time scaling is. You can tell it the data scale, the channel range, the sampling rate, refresh rate, etc. I've actually written like a kind of shortcut thing for this. I called it VizEEG. And really all it does is just run VizStream with specific parameters. You see it's looking for OpenBCI EEG. So that's the LSL stream's name. So you see stream name. So if I run VizEEG and I add to path this, if it loads, there's a lot in here. And I run VizEEG. I think it might be missing something. Hold on. Give me 1 second. Oh, we have multiple... Why do we have multiple MATLAB instances running? Oh, goodness.
That's why the CPU's messed up.
Oh, my God. Oh no. Oh me, oh my. So is this still... Okay, good. So that's still going. So if I run this... We had this working a second ago. Let's just verify the stream is still working. Yeah, we got an end byte. That would be part of why. So I need to close the stream and reset the connection. So this is like what happens if your OpenBCI happens to have a freak moment where it decides to just not be connected anymore.
Which is very likely.
It can happen sometimes. So I usually recommend that you open up the OpenBCI GUI when this happens, just to verify that the connection is still working. But you can see like I'm not in the right directory, so just give me a second. That I am not pressing the key I thought I was. That was interesting. Okay. Streaming data. We haven't gotten any end bytes. Oh yeah, where's LSL lib? Where's liblsl? MATLAB viewer, ARG system. Yeah, so you can see here we can actually receive some data in LSL. So this is like one example of a received data stream going on. And if I cancel this, if I cancel this, MATLAB is just not being very responsive today. Harrison, do you have any idea why this is moving so slow? I have to reopen MATLAB because it was like freaking out.
What's this? The computer overall?
Yeah, it's
Check
just like
task
not.
manager. Check task manager. I mean, we're streaming. We have.
Yeah, I mean
tabs
that's true. I mean it's only like 80%.
Well, if probably throttled because it was up at 100 something again. Yeah, look, it's at 100 again. Also, just remember that they can't see what you're doing in that screen.
Yeah, no, I'm just trying to spawn the stream. Hey, there we go. Give it a second. Alrighty, there we go. EEG stream, running using VizStream. So this is the same script that I was showing you guys a second ago. We had some technical difficulties. For some reason, it was like refusing to connect. But now it's connecting. And so now you can see we can actually run this and this at the same time. So I can stream and record the stream. And you can see what my EEG looks like. It auto-scales all the channels, so you see what the channels all look like. So yeah, this is an example of how you would go about doing our streaming using our experimental setup. Now, I guess just to kind of close everything out, if you want to see what's in this folder now, if we go to C/recordings, stream LSL, look, there's the old recording that we did. It saves all the previous versions. So if I were to stop this now and go back to browse, recordings, this is still here. So you can see the previous version. Notice this one's a lot smaller because we only recorded it for a few seconds. And that is pretty much it as far as how LSL works for our recording setup. So if you guys kind of follow this kind of, I guess, methodology, you will need to probably compile the LSL binaries depending upon which operating system you're using. So like for me, I use OS X for my personal computer that I walk around in. So my OS X computer is not too friendly with the precompiled DLLs and such for the lab streaming layer, so I had to compile it all myself. And the MEX files get a little bit messy on MATLAB on OS X. So just keep in mind that if you're not working on Windows, it might make things a little bit more difficult, but it certainly is doable. And that's pretty much it. So hopefully that helps you guys to kind of get a sense for how you can use our prosthetic simulation tools and how you can use the lab streaming layer. And if you have any questions, feel free to let us know. Drop them in the comments, and we will be sure to take a look at them. See you guys next time.
So we're still streaming. Hi, it's OBS that you have to stop.